Hello everyone and welcome back to Introduction to Houdini. This is lesson 2 and what we're going to take a look at in this lesson is how to do basic modeling in Houdini and what exactly do you mean by procedural modeling. Okay, so that's essentially what we're going to take a look at. So before that, let's also take a look at basic node functionality. All right, so in the previous lesson, we saw how to make nodes and how to customize them, customize the look and everything. Now, what I want to show you is when you create a node. Okay, so let's create a simple geometry folder, or let's do one thing. Let's create a box. So the thing to remember is that whenever you create any object, what you're technically doing is you are creating a geometry folder or a SOP folder. So anything that you create, you'll see that they all look the same. Like if I create a sphere, see the icons are exactly the same. Or if I create a tube, that also looks the same. And then if I create a geometry, that also is the same thing. Okay, so these basically have objects inside them and this one is empty. So that's the only difference, but they're technically the same thing. They're all geometry folders. Okay, so I'm just going to get rid of, say, 2 of these or all of them and just keep this. Now, the first thing is you get to see these 2 things on the side, this green button and the blue button. Okay, so the blue button is for display, which is if you want to hide and unhide the object. And the green button is for selectability. So once you turn this off, and if I try to select it in the viewport, then you'll see I can't select it. Okay, like let's say if I create another object on the side, if I create a sphere, and I'll move this to the side. So I can select the sphere, but I can't select this. You can select it here, you can select it in the node, but you can't select it in the viewport. That's what the green button does. And then the eye is for information. If you click on eye, it'll give you basic information about it, right? So you have like, what's the local transform, what's the name of it, if there are any constraints on it, and basic stuff like that. When was it created, how much memory it sort of takes up, like general information about it. So this is essentially creating a node at object level. Now the other thing is what you're looking at right now is you can see like up here you see some parameters, right? You have like translate, rotate, scale, but you don't really have any box parameters, right? So like again, I'm going to connect it to another software because like if you're coming from another software, it just makes it easier. Like when you create a box, right, you'll get like length, width, height, and you'll get segments and whatever. Those are not available here. Like you get a very small version of it up here on this toolbar, but there's nothing here in the parameter window because what it is showing you, like you are essentially at object level or scene level. In order to access the parameters of the object, you need to go inside. So if you're coming from a Mac standpoint, then you basically need to go to the modifier stack to start seeing the parameters of the object. When you just select the object, you're just going to get like, general move, rotate, scale parameters. So in order to do that, you just double click on it and you go inside and now you're at geometry level. And then now what you have here is this is the actual box and you'll see that now the parameters are available. Okay, so you have the size and the uniform scale. You can change the types. So you can make it polygon, you can make it polygon mesh, you can make it a NURBS sphere, sorry, a NURBS box. So you have different options. Now, before we get into, deeper functionality of this, you also have these small circles on top. Okay, like you have them here at object level. And also if you come to geometry level, you have the same circles on top, but at object level, they do something different, and at geometry level, they do something different. So just to sort of do a very simple explanation of it, if I create 2 objects, right, and if I create like another sphere, and if I connect them, so connecting is fairly simple. You click on this circle and then you drag it, and no, don't drag it, just like, move the mouse and it'll connect to the other one, and it shows you what it's doing. It's basically parenting it, which is, if I move this to the side, if you don't know what parenting is, you are essentially just connecting one object to another. So if you move the parent, like this is the parent, then the other object sort of follows it. Okay, and it's also sort of connected by like an invisible rod. So it's like if you rotate this around, you'll see that it rotates. And even if you scale it, it will scale along with that. So when you connect objects at object level, you are effectively parenting them. If you want to disconnect it, keep Y pressed and just cut it, and you'll be able to disconnect it. See, now that is gone. Like if I try to rotate it, this doesn't happen. If you want to connect it again, you can just, connect it again. So this is what happens when you're doing it at object level. When you do it at geometry level, what you're doing effectively, let me just get rid of this. So I'll just make it 0 and 0. Okay. When you do it at geometry level, you are effectively you're flowing data from one node to another. Okay, so you're not parenting anything. It's sort of like in Max or in Maya when you build like a modifier stack, right? So this is effectively that. You're essentially just attaching one modifier or one tool after the another. So it's not parenting. It's just data is flowing from the top node to the bottom node, and so on and so forth. So it goes downwards. It doesn't go upwards. Like in Max, it goes upwards, right? In Houdini, data flows downwards. So it's like if I take a transform, which is a move tool, okay, effectively what you're doing is you have a box, and then this contains, this is just, you're taking some data to move it, so you have a box and then it moved to the side. So you effectively just, it's just data flowing from one object or one node to another. Okay, that's roughly what you're doing. Okay, I'll come back to this. I'll explain it in more detail. But that's the difference between, connecting one node from, at object level and then connecting nodes at geometry level. Like they're completely and totally different. All right, so now let's take a look at the node functionality at geometry level. So at object level, you only had two of them, right? Like you had a blue one and a green one. At geometry level, you have four. Okay, so you have the light blue, and then you have a pink, and then you have like two things here. So the way it works is, I'll just do it very roughly. And I'll also create a sphere. So the blue is for display, like what you're seeing in the viewport, and the pink is for ghosting. Okay, so you can see like it sort of, if you want to see a preview of another tool, you can see it by clicking on the pink. If you click on both, that means it's showing you, the display and the ghost both. So this is roughly what the pink one does. If you also keep the mouse on it, it will give you options, right? So if you control click on this, you can set a render flag. Okay, what that means is that if I control click on the box, okay, you can see like the color changes. This sort of changes to a violet. I guess that's a violet. And then this becomes like a dark blue. Now what's going to happen is if I try to do a render, okay, just to sort of give you an idea, you can also render without taking a renderer. It'll do like a dummy render. But if you render it, once it generates the scene, which takes a little bit of time, the newer renderer is a lot faster. The older one was slower. Yeah, so you can see, like, you see the box. So what's happening is that you've kept a display node for the viewport, which is going to show you the sphere, and at render time, it's going to show you the box. Okay. And if I change that, if I come back in here, and you can control click on the sphere itself, now see it's gone back to being a light blue. If I hit render, now you'll see the sphere. See, so now I can see the sphere. And then if I just change it, you can just, switch. So this is effectively what, these two things do. Now, this one on the side is essentially for a bypass, but that's primarily for like modifiers or tools. Here it won't make any difference. But effectively, if you've taken some modifiers, or in Houdini language, they're called SOPs. So if you've taken a SOP, and if you want to bypass a particular SOP, you can click here. Okay, sorry, that one, the last one, which is yellow. Okay, so yellow, as it says bypass. So you can bypass a particular node if you want to. And then the middle one, which is the red, is essentially a lock. So what that effectively means is usually individual data is stored within individual nodes. If you want to lock a node completely, what it effectively does is it discards all the data it has on top and locks everything into a single node, which is effectively like freezing. Okay, like if you ever frozen geometry in any other software, or I think in Max you would collapse, right? So if you have a modifier stack and you just want to collapse it down to a single object and you don't want the modifiers anymore, this is effectively what it does. Like it just collapses and then you can delete everything on top. The problem with that to remember is that if you decide to, you can unlock it as well. Okay, but if you decide to unlock it and if there is nothing on top, the geometry will just disappear because it's trying to look for whatever was there before. If you deleted it, it's gone. Okay, so be very careful when you want to lock it. Usually you very rarely want to lock it unless you just want to lock a geometry and send it to someone and you don't want to show your entire process and just send them a piece of geometry, then you can lock it this way. So that's effectively it. This is, basic node functionality. So now let's talk about, modeling in Houdini and what is the advantage of node-based modeling. Okay, that's the first thing we want to take a look at because this is essentially a node-based system. So what is the advantage of having a node-based system? Okay, so to give a very simple example, let's first take a look at one basic tool and then we'll, kind of work from there. So let's say you just want to move this. Okay, so when you select a node, it does have some basic, move, rotate, scale options in there, but you also have like a move tool, okay, which is called a transform. So press tab and take a transform and you'll get a transform node. And you're getting like this warning sign on it. What that essentially means is that this node on its own can't do anything. So some nodes create stuff, right? So you have a box, you have sphere, tube, as we have seen, like those nodes create things. If you have modifiers, they don't create anything. So you need to connect something in there, right? It says require transform geometry. So you need to feed it something for it to start working. So in our case, we want to feed the box in there. So we can just connect that. Okay, so once you've done this, now I want to start moving it. I can move it to, one side, but you're not seeing anything happen because the display flag is still here. Okay, so Houdini doesn't automatically activate the display flag for the lowest node. You have to activate it yourself. Okay, so what you need to do is you need to come here and activate this, and then you can see the final display or the move that you've done. So the thing to remember also is that whatever object has the display flag is what you will see, or whatever sort of node here has the display flag is what you'll see in your render. Okay, so like if I created a sphere and I created a tube, and if I go up here, you're only going to see the box. Okay, because there is no display on these. So if you want to see multiple objects, there are other ways to see it. But the thing to remember is that whatever has the display is what is going to be, seen and rendered. So I can take a transform and I can move it. Now this is what is, okay, so let me just get rid of, these two things for now. Okay, so let's say, what is the advantage of having a node-based system, right? Like what exactly do you do with it? So usually, let's say you are in any other software and you want to create 4 boxes. How do you go about doing that? So the simplest way is you can just take this, you've created one box and you've moved it. I can just do Control C, Control V. So I have another box. Let's say I'll move it here to one side. And then I can take a third box and I can move it here. And then I can take, it automatically keeps the, the ghost mode over there, or what's called as template. And then I can do a 4th box and I can move it there. So I have 4 boxes, right? So this is fine. But now the big question is also, how do I see all of these? Because when I come up, I only see one of them. So the simple thing is you need to combine them together, which is done using a merge node. So in some ways, it also works a bit like a compositing software. So if you worked in Nuke, then if you have multiple footage, then you have to like merge all the footage together. You need to combine all the footage together. So that's effectively what you're doing. So just press tab and take a merge. So merge doesn't really have any parameters, it's just there for merging. So what I can do is I can just take all of these and then you can do it one by one. Okay, or you can just like press Y and disconnect it, or you can take all of them and connect it. Okay, and then put the display on this and you have 4 boxes. So this is okay, like it's not bad, but this is also not a good advantage of having a node-based system. So the advantage of a node-based system is essentially you can branch things out. Okay, you can have one source geometry and you can branch it out and then you can merge it back together and you can, like effectively multiply that one geometry. So what I can do here is I have this initial box, right, which is still there. And I can just get rid of the 3 boxes from here. Okay, so the great thing about this is that even if I delete the boxes, I'm not going to delete the transform or not going to delete the move, because the move isn't stored on the box node. The move is stored in its own node itself. So if I delete these and then all I have to do is I can just take this same box and just plug it in here. And what you've effectively done is you've taken this box, you moved it to different places, and then you bring the merge back, you effectively get the same result. Okay, except that you didn't have to make 4 independent boxes. You just made one box and then you could move it. Okay, and the interesting thing is you can actually still bring back the original box as well. So if I take this original box and bring it in, you technically have 5 boxes now. So we started with 1 and then you sort of, moved them around and then you merged them back together and you effectively ended up with 5 boxes. So the great thing about this is that if I make a change here, okay, like if you want individual boxes, you can have individual boxes. But when you want to do something like this, I just want to increase the mesh. For all of them, I can just increase that. So that isn't a problem. But you can individually also go and like maybe this one needs to be scaled up, so or this one needs to be rotated this way. So you can still do those things, but you're still effectively bringing in stuff from, one single area. So this is, effectively a really good advantage of a nodal system. So the crazy thing that you can do here is I can also animate one of the boxes, okay, without it affecting anything else. So what I can do is, let's say if I take another transform and I want to transform it in the middle over here. So what you can do is you can just take this and drop it on that. Okay, and it'll automatically connect. And you can also rename them. So let's rename this to animation. Okay, so I can just take this and let's say I want to animate this. So the shortcut is keep Alt pressed and we'll click on the Y axis, the translate Y, and make sure this is kept to auto. Like right down here, you can see like there's a key and it says auto. If it's not on auto, you can just turn these two on. Like click on the arrow, it says auto key changes. So you can automatically do, keyframing. So I can just come up here, I'll bring it up and then I can come down there and bring it down. And then I can come back here and make it 0. And so what you've done effectively is, see, so you have these guys are static and then this one is animated. And this is effectively, a great advantage of having a node-based system. Now, how does this translate to a procedural system? Okay, and this is where Houdini becomes great. Is because data isn't stored on the object itself, transferring it becomes very, very easy. Right, so all of this data here is stored there. Like the box itself is not doing anything. Right, it's these individual nodes that are doing stuff. Right, so this is my animation and then this is moved here and this is moved there. Okay, so all of that stuff is here. So as I had mentioned in the previous video, that effectively what you're doing is you are setting up a series of rules. So you can think of these things as rules. Okay, I've taken an object and said, okay, like do all of this stuff with it and then just merge it together and show me the final result. That's effectively what you've done. So the great thing is I don't want to do it on a box. I want to do it on a sphere. So I can just take a sphere and then I can just replace this. So if I want to just replace two of them, see now you're just replacing two of them. But if I want to replace all of them, I can just replace all of them. And so what you've done is you effectively just replaced all of that with just, a sphere in half a second. Everything else remains the same. You get the same result again. It's just the object is different. Now, before I continue, I'll just cover one more thing, which is essentially from a functionality standpoint. I had accidentally done it in the previous video. I didn't want to, it was just, a force of habit. But we'll just quickly take a look at something called as the numerical ladder, which is essentially a great way to just, modify parameters. So effectively what you do is you come on any parameter, and if you middle click, it'll give you this thing called a numerical ladder. And you can just increase, decrease values in like really controlled ways. So if you want to increase something in 1, 2, 3, 4, you can do that. If you want to increase it in 0.1 or 0.01 or anything like that, it becomes very easy. Also, like if I change this to, let's say, polygon mesh, and then I want to increase the number of segments in like 10, 20, 30, 40, you can do that. You want to increase it by hundreds, you can do that. Sometimes you don't want to do it because it just might give you way too much geometry, but it's very easy to just, middle click on anything and just modify. So that's something I needed to cover because it is a pretty decent functionality to have in there. But yeah, coming back to this is effectively what is the general advantage of having a procedural and a node-based system. Okay, so the great thing about this is that not only can you branch things out, but you're effectively, let's say you need to do a logo animation, right? The logo isn't ready as yet, but you have a rough idea of, this is what I want to do. So what you can effectively do is you can do a full animation setup or an effect setup. And then once your logo has been, like, let's say there's a separate modeling department. And once they have modeled the logo and sent it to you, you can just replace it. And everything still remains the way it is. You just, plug out your base geometry and plug in the new logo that you've made, and you're effectively done. You don't need to do anything else. So that's essentially the great advantage of having this. The other great advantage is you can also sort of experiment without destroying, a piece of geometry. So if you've done some basic modeling and you're not, happy with it, you can sort of branch out and do other things. I'll explain that in a bit, but that's also another example of what is the advantage of having a procedural system. All right, so before we move on to other examples of procedural modeling, let's take a look at one more concept, which is effectively called channel referencing. So the point with channel referencing is it's fairly simple. You're essentially connecting one channel or one parameter to another parameter. So this is a channel, like this, like translate X or translate Y or any of these are essentially channels. And then you can sort of connect one channel to another channel. So it's nothing complicated. The advantage of it essentially is that when you're trying to build a complex structure and you want interdependent parameters, like let's say you have a table and you've kept something on top of the table, and you want that anytime I increase the height of the table, that object on top should automatically adjust. That's effectively where channel referencing comes into play. So I'm just going to, you can delete this or you can just keep it to a side. And what I can do is, I'll just take another box. One of the very simple usages of channel referencing is usually when Houdini creates an object, it creates it midway. So half of it is down and half of it is up. If you want to move it on top of the grid, what I can do is I can just take a transform and let's rename this to move to grid. With Houdini, the one thing you should be comfortable with is you should be comfortable with using a little bit of math, because you will end up using it in a lot of places. Usually not complicated, like I don't know a lot of math, but usually it's like a plus minus, or this is greater than this, or this is lesser than that. It's usually something like that. and a little bit of coding. Again, I'm not a programmer, but a little bit of coding, you'll eventually get used to it. So what I want to do here is pretty simple. I want to take the Y size of my box, okay? And then I want to use that to move the object up in Y axis. So I can just take this and I can right click here on any parameter. So in this case, I want to take the Y size and I can say copy parameter, and then I can come to move to grid, and then I have the translate Y, and I can right click here and I can say paste relative reference. Okay, so which is essentially the name channel referencing. And once you paste it, you'll see that the box moves up. So what you've done, the code is pretty straightforward. CH is the code for channel, okay, or the function for channel, and the rest of it is just the path. Okay, so what you have is, it's essentially a directory structure. So you're saying like // which is the current directory, box2, which is the name of the node, and this is size Y. Okay, so if you come here and if you keep your mouse on this thing, you'll see that the parameter is called size, and the parameters inside it are called size X, size Y, size Z. So you can actually see them here. Okay, like these are the names that you'll need to use. So it's TX, TY, TZ, or rotate will be like RX, RY, RZ. And uniform scale is called scale. Okay, so whatever is the name over there is what I want to use. So if I want to change this, let's say I want to connect it to scale, I can just come down here and I can change this to scale. So what you're doing now is, if I come down here and the more I increase the scale of my box, the higher up, see this thing, it keeps sort of going upwards that way. Of course, this isn't what we want to do. So I'll bring this back to 1 and we'll take this back to, I believe it was called size Y. Now, the problem is that size Y is moving it up too much, right? Because what we want to do is whatever is the height, we want to move half of that up, right? So technically you want to divide it by 2, which is basically what we want. So it's simple. You just come in here and you click divided by 2 and that's it. So now whatever is the size of the object, you will always be on top. Because that's what it says. This is 2. Let's say this is 2.4. If you come back to the grid and if you click here, it will remove the function and show you the actual numerical value. So just click on this. You'll see it's moved up by 1.2, right? So this was 2.4, it's moved up by 1.2. So that's effectively what channel referencing is. Okay, now let's continue this a little bit more. So let's say this is the object that we've taken and then we've moved it above the grid. And then I want to take another transform. And because everything is just 1 over here, if I start scaling it in this particular node, this actually becomes the size of my object. So let's just call it size. Okay, and then I can just take the Y size and probably move it up. Now what I can do is, let's say I want a sphere on top of this. So I can just take a sphere. And with the sphere also, it's halfway through. So first let's get the sphere on top. You can actually take another move, but we can do it inside this thing as well. The reason we do it with other nodes is that it's better to have data in separate nodes, so that if you want to plug something else into it, it becomes easier, right? Like that's one of the reasons why you do it. So what I can do is I can just come in here and I can say, we can do the same thing. I'll right click here, take copy parameter, take another transform. Okay. Or actually, yeah, and then just, do the same thing. So connect it, we'll call it move to grid, or so this is move to grid, this will be move to grid 1. And yeah, copy, I think I'd already copied it, paste relative reference. Yeah, so here you don't need to divide by 2 because this is essentially radius. Okay, it's not diameter. So since it's radius, it's already half the value. So you're just, you're getting it up by 1. And then what I can do is I can take another transform and I want it on top of this box. So I can turn on the template. So that's where my box is. And this size technically is the height of the box. So I can right click here. I can say copy parameter, and I can call this, say, move to box. Okay, doesn't make much of sense, but okay. And then I can come into translate Y here and right click and do paste relative reference, and there you go. So now if I merge these two together, so whatever I do, if I increase the size of this, you'll see like, that's always connected on top. And if I adjust the size of this guy, you'll notice it stays there. Like what you can also do is, if you want, we can try and like, do maybe like a scale here. So just for fun, right, I can take this and I can probably connect the Y size also to the scale. Okay, so I can do right click, copy parameter, let's call this scale. And I'll come to uniform scale and do paste relative reference. But let's do divided by 3. Okay, so it's pretty small. So what will happen is that as I scale it down, it becomes smaller. And as I scale it up, it becomes bigger. So nothing fancy, you're just connecting parameters. Like once you get it in your head of what you want to connect and where, you can do a lot of really interesting things with it. Okay, so this is effectively what channel referencing is. Okay, so this is, as I said, this is the nice thing, right? So I still have this thing here, which I had done, and I had this thing here. So the advantage of a system like this is that you can actually have like multiple tests and experiments and everything lying inside one single folder. And then you can just pick and choose what you want to see or what you want to render. Okay, so you don't need to delete anything from your scene to make other stuff. You don't have to worry about any of that stuff. It's just it's like a flow chart, which is just, an infinite area that you can just keep making as many as you want. All right, so we've covered the two basic things, like the advantage of having a nodal system and how data is stored within nodes, and then the advantage of, channel referencing. So now let's move on to procedural modeling. What are the advantages of procedural modeling? So I'm going to start off with, this is an example I've done many, many times, but it helps a lot. So I'm going to make a tube. And what I want to do is I'll just reduce the height of it. And I'll turn this into polygons. So I have about 12 faces. And I want to select alternate faces and just extrude them. Okay, so I can come into the viewport, and by default it allows you to select faces. If you can't, the shortcut is fairly simple. So 2 is for selecting points, 3 is for selecting edges, and 4 is for selecting faces. Okay, so I can select 1, 2, 3, 4, and 6. Okay, once you've selected this, you can press tab and type in poly extrude. So take poly extrude and it'll automatically connect a poly extrude here. And then you have a handle, you can just pull it out and we can do a little bit of inset. That's effectively it. So this is how you can do standard modeling in Houdini. But the problem that happens, and which happens with almost any software, is that if I go back to my tube and if I start to change some parameters, then this system essentially breaks. So if I start to change the number of columns, then you'll notice that the newer faces that got added, they don't get extruded. Okay, you can just extrude, like what was the existing selection is what got extruded. And that is one of the important things about having a procedural system. So the point is, most softwares have some level of proceduralism inbuilt. But to build a truly procedural system, what you need is access to almost every single operation or piece of information that is going into building something. And that is what Houdini really gives you. Okay, so whatever you're doing, Houdini kind of has a way to store every single piece of that information, so that the system or whatever you're building, the rules that you're applying, they won't break. So to give you a very simple, so if you take this example, what exactly happened, right? We made a selection and then we did an extrude. What is the information that you don't have? The information we don't have is the selection, right? The polygons that we selected are the ones that are being fed into the poly extrude, and we don't have a way to access that. If we had a way to access that, we could probably modify this. And with Houdini, you get a way to access that. So let's just take a look at this first, right? So if you come down here, and I'll bring this back to 12, and if you switch this on, which says primitive numbers, so every polygon or every face has a number. And if we template the poly extrude, we can see the ones that we selected. So we selected 0, 2, 4, 6, 8 till 10. So if we could get access to this, we could effectively change the way the extrude is happening. And the great thing is, as I said, Houdini does give you access to that. So if you come to the poly extrude and if you come to the top, you'll see it says something called group. Okay, so a group is nothing else but a selection. In Houdini, selections are called groups. That's effectively it. You don't need to think about it too much. And you can see that it's actually giving you the primitive numbers that you had selected. Okay, so if I come in here and if I delete these, if I just keep 0, now you're extruding 0. If I delete all of them, it will just extrude everything. If I say I want to extrude from 1 to 5, I can actually type in and now I'm extruding 1 to 5. And within the poly extrude, I can say divide into connected components, or I can say individual elements, so it will extrude, like individual elements. So this is one way of doing it. So the advantage now is that if I increase this to say 40, and then I can come down here and I can actually, type in if I want to. This would be too crazy, but you can do stuff like this and extrude. But that's, this is not a good way to do it. So what Houdini does is it gives you multiple tools for making and storing selections. And that's a huge part of how you can, how you can make a procedural model, or how you can make the system procedural. So we're going to take a look at a few of them. Okay. So if you press tab and you type in group, you'll get a whole bunch of these. We're not going to go through all of them, but there are, quite a few that are really important. So the default one is called group. Okay. And what group does, what we're going to do is we're going to put it between the operation and the object. Okay. So this is my object. Then I want to create a group, and then I want to feed that group into my extrude. That's roughly what we want to do. So I can just take the group, drop it in the middle. It has two inputs. The second input is optional. Usually, if you look at it, whatever shows you the red arrow, okay, or the pink arrow, is what is required. Okay, the other one is usually optional. So if you put it in, it's great. If you don't, it's fine. Okay. If you get something which says like both of those are red, that means you do need two inputs for it to work. So I can just drop this in here, and it has multiple ways to create groups. The default will select everything. One is you can type in primitive numbers and have those. Okay, so you can actually if I select this and I press 4 and I select some faces and I press tab and I take group here, you'll see that it automatically takes that selection and makes a group node out of it. Okay, you can do that as well. And we can give this a name. So I can call it extrude. So I'll just call it ext. And then I want to extrude this particular thing. So I can come into poly extrude, and instead of 0, I can type in ext and press enter, and there you go. Okay, you can also get it from a drop down list. Like if you click on this drop down list, whatever groups you have, it will extrude those. You can have multiple groups. Okay, so if I take another group node, and I can select this and I can say exta. Okay, so if I come down here and you'll notice that, now there's ext and exta. You can take both as well. So I can do this. Okay. Okay, I think there's something wrong here. Yeah, okay, sorry. This didn't. So, okay, so since we took this manually, how do you make a selection? So the option is very simple. You can come to base group and you can click here on this arrow, and then I can make a selection and press enter. So it will select that. Now if I come back here and see, so I can just do spacebar in ext. So you have two selections. Okay, so you can and if I bypass this, so this is what a bypass does, right? So which you didn't see happen before, but this is a bypass. Okay, so this is one way that you can make procedural selections. Now this is still not very procedural because you're manually typing in numbers, but you can do other things. So if I turn off base group, and you can take something called keep in bounding region, okay, and you get like a bounding box. And so I can move this bounding box around, and wherever that bounding box is where your selection will happen. So now you are excluding based on this. And you can actually animate this. So I can keep it here, and I can just alt click, I can come a little ahead, and I can move this, okay, to that side. And then if I play this, see, so you can actually you can animate and exclude happening. Pretty straightforward. Okay, let me delete that. I don't want the animation. So you can right click here and you can just do delete channels, and that will delete the animation. You also have other ways of selection, but we'll come back to those. Okay, but this is pretty basic. So another option you have within bounding boxes is you can have a bounding box, you can have a bounding sphere, but you also have a bounding object, but that only takes points. So we'll come back to this one in a minute. Now another way of selection is if I just keep this to a side, and if you type in range, then you'll get something called group by range. And group by range is really useful for us for what we want to do, because it allows you to select and skip polygons by a given range. Okay, so I can just plug this in, and we can call this ext as well, so that it's the same name. It's easy to do. And so firstly, you have options here. So you can skip a certain number of start faces and a certain number of end faces. So I can just say skip the first 10. Okay, so I can skip the first 9, or I can skip the last 9. And then you can also, by default, it says select one of one. So it's selecting, everything. If I say select one of every 2, then you're selecting that. Or if I say select one of every 5, then you're selecting this. Okay, so it's pretty easy to work with this. And this is where your system gets really interesting, because if now I come in here and I replace this with a sphere, and I'll change this to polygon, because by default it's kept to something called primitive that doesn't really have any polygons. But if I change it to polygon, and if I plug this in, you'll immediately see that you're now excluding based on this. So the same rule is applying. Okay, like if I change it to this, or whatever you want, you can very easily just make those changes. If I change the number of, yeah, see, so it's pretty easy. So you're not breaking the system at all. What you've done is very simple. You're just saying select one of every 3 faces and then exclude them. So no matter what comes in, it's always going to do that. Okay, so if I take a box, I can give it some additional polygons. Let me just increase that. And if I feed it in, and see, there you go. So every single time you'll keep getting the same result. Okay, so this is what effectively makes it procedural. So it's having this kind of access is what makes the whole system as flexible as it is. Okay, the third type of grouping that you get is something called as group expression. Okay, so these are the 3 most important ones. So I can take a group expression, and here you can do some basic math related stuff, and I'll use like a vex command, but I will be doing another vex lesson anyways, so we'll cover in that. But just to do a very simple thing, I want to select, let's say, all the faces that are positive of the x-axis. So the code for position is p, and you want the x-axis in that, so it is essentially p.x. And since it is coding, you always need to add an at sign before it. Okay, like that's the function. So you take an at and it's p, which is position, dot x. And we say p dot x is greater than 0. And you selected everything that, see, so that's the x-axis down here, like if you can see there. And so this is the positive, that's the negative. And I can just, I'll call it x, that's the group name. So I can feed this into poly extrude, and you'll have to change the group name, we'll call it x, and there you go. Now the advantage of something like this is even more interesting, because this is selecting based on the position of the object. So if I take a transform after the group, nothing is going to happen because the group is happening first and then you're moving the position. But if I take the transform before the group and I start to move it, you'll see that the extrude changes, because what's happening is that if you look at the grid, now we're completely in negative of x. So there is no face to select. Okay, so as you start coming into positive, it automatically starts selecting the faces. And as you go into negative, it will get rid of the selection. And it will happen with anything. So if I feed in a sphere, it's the same thing. So as I said, what you're doing is you're setting up a bunch of rules. And then if your rules are correct and they've been set up properly, no matter what you feed in, you'll keep getting the same result over and over again. So the system doesn't break. So if, let's say, you've done an animation like this, and later on your actual geometry is going to come in, you just replace the sphere with your actual geometry and you get the same result. So life becomes very easy. Okay, now as a final thing within groups, I'll do like, a couple more of them before we move on. So let's just change this again to, yeah, and I believe we were selecting by bounding box. Okay, so two more nodes that I want to cover. So one is a new one, which is called group expand. So if I take a group, and you'll find something called group expand, which is pretty simple. It can just take any selection and just expand it. Okay, so the group that we want is ext, and if you click here, and then you just have an expand option. See, so you can actually just, expand based on this. So if you go to negative, it just removes the selection completely. But you can just, so if I come in here, and we can call it the output group. Yeah, let me just see if this works. Yeah, so this doesn't work right now because you need to give it an output group. Okay, so if you just switch on output group, it just feeds it into the existing group itself. See, so this is a great way to animate. Like if you want to just animate a selection expanding, you can do, something like this. The other option is something called as group combine. So a group combine is fairly simple. It basically allows you to combine multiple groups together or also create inverts of groups. So let's say I have this selection and then I want to select the opposite of this. So you can do stuff like that with a group combine. So just to show you how it works, you can take a group combine and you can drop it in, and this is ext. So let's call it, we can say xt is equals all but ext. So see, so what you've done is you've selected the opposite of this. So if let's say I want to take another poly extrude, and let's see if this works. So let's say this is poly extrude space ext, and I can say poly extrude space xt, and I can plug this in, and I can just pick up xt, and I can say this will be a negative extrude, and it will be like individual elements. So we have something like this, a little bit of inset. So now if I come back to this original group and I make changes, see, as all of it removes, it goes negative, and then as all of it comes in here, it goes positive. And the interesting thing here also is that if I replace this with the group range, you still get the same result. So I can just plug in the group range, and what you're getting is the positive ones, which are the ext, those are going out, and whatever is the opposite of it, they go inward. So you can very easily make, stuff like this. Or let's say if we take the group expression and call this ext as well, so it's easier. So I can plug this into group combine and see. So now if I take this and I move it around, see, so as it goes into positive, it comes this way, and as it goes into negative, it goes the other direction. All right, so this is essentially how a procedural system works. So as I said, like every software gives you some amount of proceduralism. The advantage of Houdini is the level of access that you get. Okay, so if you weren't having these kind of selection nodes or group nodes as they're called here, you wouldn't be able to do half the things that this is able to do. Okay, because you do need that level of access to information and data for you to be able to build a system that won't break. Okay, because if you didn't have access to this, it's really not going to happen. Before I close this lesson, let's do something very simple. So last lesson when I was talking about a procedural system, I said, okay, you can select the top faces and then grow some plants on it. We won't create a plant, but let's just look at something like that. Okay, so just to give you an example of how a system like that works. So I'm going to take a sphere. So let me just take a sphere. And what I'm going to do is, first of all, let me just let me change this to polygons. And sometimes you end up seeing like a previous mesh. If you just change the parameters of this, it disappears. Okay, like it's a small bug in the viewport, but yeah, it happens sometimes. Okay, so I'll just increase the frequency to get more faces. And then what I want to do is I just want to distort it slightly. So you'll get something called as mountain. A mountain is essentially like a displacement with a noise map inbuilt. So I can just put in a mountain and see. So you'll essentially get that. And you can define the height of it. So I'll just do about that much. You can define the element size. Okay, so this is fine. Now what I want to do is I want to select only the top faces or faces that are pointing upwards in the y-axis. So I can take a group node, and within the group node, you'll find something called as, let's call it top. Okay, so I can just come in here and type in top. Now another way of giving a group name is there is a function called $OS, which is the name of the group, the name of the node itself. Okay, so what I can do is if I call this top, and then if I come into group and call it $OS, so what happens is you effectively just, like if I come back here, you have created a group called top. Okay, so whatever is the name of the group. So if I call it BOT, and then if I, click on it again, you'll see that the group name changed to BOT. So you don't, if you want to name groups based on the node name itself so that it's easy for you to remember it, whatever name you put here, if you type $OS, that's the name it will pick up. Okay, so it's nice. It's a nice way to do it. Okay, so now we have done that much. Now let's select the top faces. So I'm going to turn off base group, and you come to keep by normal. And it can allow you to select by normal. So I want to select in the y-axis. So keep direction as y1, okay, and make this 0. And then just start to lower. Okay, so I think there's an issue. I can't. Yeah, okay, it's not showing it to me in shaded mode. Yeah, but you can see it here. Yeah, there you go. For some reason, it's not showing it to me in shaded mode, but you can see it, in the wireframe mode. So what I want to do is I can just bring down the spread angle, and you can see like we are around 56. I think this is fine. Okay. So these are the top faces that I want. And then I want to scatter some points here. So I can just take a scatter. So a scatter basically just, generates points. Like if I connect it directly to the sphere, you'll see that it just generates some points. Again, like let me just change this. Yeah, see, so it just generates some points. So if I plug it in after the top, it's scattering to everything, but I can change the group to top. And see, so now it's only scattering to the top. Okay. And I can also say, you can have a total count. So it's giving you a total of 1,000 points, but I can turn that off and I can say go by density. So the interesting thing about this now is that if I come down here and as I increase this, you'll see like the point density keeps increasing. Okay, now I just want to create something. So something that, I don't know, we can use as grass or whatever. So I'm going to take a simple line, okay, which is like a straight line. I won't do anything with it right now. Like I won't bend it or twist it or anything like that. Okay, all I want to do is I want to select the top point and copy a sphere on it. Okay, so it looks something fancy. So I'll give it a few points. I'll give it about say 8 points, and I want to select the topmost point. So the way to do it is you can take a group and we can do a group by range. What I'm doing is everything that we've done over the period of this, of this video, I'm just putting it to some practical use. So you get an idea of, what you can do with this. So I can say group by range, and we'll just call this T. As I said, you can go either ways and change the group type to points because we don't want to select primitives is the whole thing or faces, and point is the points or the vertices. Okay, actually vertices are different from points. A point is just a point in space, in 3D space. A vertex is something that's connected to, faces. Anyway, so what I want to do is I want to select the top point. So you take the end and you keep it to 1. So it will deselect the top point, and then click here and say invert range and you'll get the top. So that's great. Now let's take a sphere and I'll make it really small. So I can just take this and scale it down, and I want to copy it to the top. So the way that works, and we'll be doing copies in more detail in the next lesson because there's a lot of stuff that you can do with copies. Okay, but what you can do very simply is there's something called as a copy to point, okay, which allows you to copy geometry onto points. Okay, so I'll just take a copy to point, and I have my line here and my sphere. And now see, this has 2 arrows, which means it needs both. It needs the base geometry and then it needs what you want to copy it to. So I can take the base geometry and I can keep this. And so right now it will copy to every point, but we just want to copy to top. So if you select this and it says what are the target points, which is essentially your group, you can say T, and there you go, it selects to the top. And now in order to complete this, we need to merge them together. Okay, so you can take a merge and I can just merge this and that. So there you go. Okay, so we have, it doesn't look anything fancy, but it's just it's a lollipop. It's like a stick with a ball on top. And then I want to copy all of this onto these points, like these points that we've generated. So we can again take a copy, same thing, copy to points, and I can just do the same thing. We don't have to select anything here because they're essentially just that. And let's just make it small. So we'll take a transform in the middle here and I can just make it small. So I can just take an attribute scale. Sorry, I can just take a uniform scale and scale it down. And then if we merge these two together, like all of these, so I can call these my plants, and I can plug in this, and then I can just plug in this guy. So what you've done effectively is you have this little rock with plants on top. And if I come to the top and I make changes, see, you can effectively copy this. And this is where it becomes great, is if I change the base geometry, and let's say if I take a test geometry like we've done last time, and I pick a pig head, like you get something called a pig head. Okay, I'm going to remove the shader for now. And if I just plug in this guy, and you'll see that you get the same result. Okay, like if I get rid of the mountain for a second, see, or if I take another test geometry, let's say I take rubber toy, and I'll turn off add shader, plug this in, see. So what you've effectively done is you've just, So anything that you want, you can essentially just bring it in and it'll make changes accordingly. And even if you come to like, this one and I make some changes to the noise map, see, this will keep adjusting. All right, so this is effectively it. So this is the basics of the advantages of a nodal system, what is the advantage of procedural modeling, and how using basic channel referencing and group nodes, it helps you to build a more break-proof system, which is essentially what you want to do. You want to build a system. So the whole idea behind Houdini is not to just do like straightforward modeling. The idea is to build systems. Okay, the idea is to build something where no matter what you feed in, you can keep getting similar results over and over again. So effectively, you're building your own plugin. So every time you want a similar result, you just feed in any geometry and you get the same result again. As you can see what's happening right in front of you. All right, so in the next video, we're going to take a look at a couple more concepts, which is primarily we'll take a look at attributes. So attributes is a very, very important concept in Houdini. And we're going to combine that with effectively what is called as what is your copy tool. So we're going to see how to use attributes and use those to drive parameters, and also how to use those and drive various copies and generate more complex stuff. So I'll keep this as an example and we'll try to make it more and more detailed as we go along, so you get an idea of what you can do with it. Okay, so keep watching.